Hello everyone. We introduced in the latest video inventory with event sourcing, and today we will look into one issue that we might have with event sourcing, which is often called eventual consistency. And there are actually several ways that we can fix this issue. Let's say you have finished your daily quest and you get 100 gold, and this 100 gold is added to your inventory and the client sees 100 gold. Everything is fine. Adding things to the inventory might have a delay till the client is able to see it, because that's eventual consistency. Now let's imagine we have two services. One is our quest service and one is for trading with other players. And both get at the same time from the same player that he wants to spend his 100 gold to finish the quest, and he wants to spend the 100 gold to trade this gold to another player. And if he managed to do it in a quite fast fashion, so pretty much directly, that those both services gets remove 100 gold from the inventory, when they ask the inventory how much gold does the player have, both get as a response the player has 100 gold. And when those services now add to the inventory events remove 100 gold, then we will remove 100 gold twice, even though the player doesn't have 200 gold. This is a known issue for eventual consistency, and there are actually many ways to fix this. One way would be that those services don't directly add the remove gold event to the inventory. They check the projection and check if there are new events available. This doesn't solve the issue completely, because there's still a small chance that when they read if an inventory is item, are there more events, that it's quite luck if the remove 100 gold event is in the database or not. Another solution which I often found online, and I talked with my cousin who is using event sourcing in some projects quite successfully and who has some knowledge about this issue. Another thing that you could do, which I tried not to solve it that way, is you could introduce another service which is only this new service. Let's call it inventory, sorry for caps, inventory event producer, and he has a queue in front of him, a queue, and you add your events to the queue, and those at the bottom both add remove 100 gold, and it will process the queue, but it will retain an internal cache and knows that one of those events will fail, and then it will, in the best case, notify the producer that an event has failed. The issue that I have with this way of thinking is that I don't want to have an internal cache, because your whole business logic about inventory is within this service, which is not a bad thing. Having your business logic contained in one service is not a bad thing. And reporting back also is possible, and we could make leverage our pub sub to do it, maybe as we subscribe to the event ID and we publish the event ID failed or successfully, and we could make this work. And this is actually one approach I was thinking about implementing, doing that. The only problem, what I really don't like about this approach, is that we have an internal cache within this service who acts like a database. And it feels like, why do I want to do event sourcing when I have a database at all knowing everything? So why should I go to the projection when I can ask the producer, because he already knows all the events that are in the store and everything. Another big issue might be replayability. So when we restart the services, all read models has to replay all events. If the database is lost, the projections are written that way that you can do that. But what about this producer? This producer also has to read all events again and fill its own cache. And honestly, that feels a little bit slow, and I don't like the idea, because I think when I do it that way, I could introduce another database. And that's actually what other people also suggest, is to have another database with a consistent state. If I do that, then I might remove the inventory event sourcing completely and just use this database. But how do we implement it, or how did I implement it? Honestly, if my implementation is superior of this implementation, I can't tell for now. We will have to have it run in a lot of test scenarios and maybe in production to know that. But what I did is I implemented, because Cosmos DB is very easy capable of doing that, an inventory events list model. The advantage to introducing another service, adding gold or items to the inventory, which is what happens most of the time. There are very few times when the player will lose something. Most of the time he will hunt mobs or collect some goods from the map, and most of the time, most of things that happens to the inventory is adding stuff to the inventory, and removing is not a common occurrence. But often in games you see that there are issues with, for example, finishing a quest and at the same time dropping items on the floor, or trading items with another player, or something like that, or trading items with another player and dropping items on the floor. And if we don't fix this concurrency issue here, this race condition, then the player is able to dupe items. That's what happens in most games with that issue. And what I introduced in the code is the leasing system. What that means is, if you want to add items to the inventory, you can still do it. You can still directly write an inventory event at 100 gold, and it will eventually get into the projection and the client will see it. But if you want to remove, then the client already sees it, so we don't need to check for any consistency with adding data. So the client sees he has 100 gold, and now he wants to trigger. What these services will do, they will try to acquire a lease. And only one of them, no matter how fast and at the same time it will acquire the lease. And only this one is able to remove the 100 gold, and the other one will fail. Now, how do we manage leasing? because let's say Quest service will acquire the lease and it doesn't add the event and it will crash. Then we need some mechanism that the lease will get free again over time. So what we add is simple, the lease will get a timeout. Let's say for now 10 seconds. So if if Quest crashes, then after 10 seconds the lease is fine, and if the player then decides to trade again, the lease will acquired by trading, and trading is able to remove the 100 gold. As you can see, we need a retry mechanism when this leasing is blocked. Let's say I have 200 gold in my inventory and I want to finish the 100 gold quest and I want to trade 100 gold. I do both pretty much at the same time. Let's say Quest gets the lease, but trading doesn't get the lease, and Quest remove 100 gold. Then we need some mechanism to know that trading will get the lease. So trading will retry to get the lease. It will try a second time and maybe a third time is needed, but one day it will acquire the lease. Let's say trading gets the lease. Now trading needs to re-get the inventory. It knows that because it just got the lease, and after it got the lease it will read the inventory. How does it know that the inventory is up to date? Because we are eventually consistent. When you acquire a lease, I force you to add an event to the inventory events, and when you acquire the lease you will write the timestamp of this inventory event in the lease. So what I do now, when trading acquired the lease after Quest is done, it knows what timestamp the event from Quest was. So it knows when the last removal event of the inventory occurred. And now it will ask inventory to give the projection and tell him if the projection is up to date till this event. And if that's the case, then trading knows that the removal event of the last lease is processed. And it then can check, is still enough gold in there, yes or no. And it knows that the removal event is processed and that there are no more removal events. There could be another event which adds more gold. It doesn't know if that's in the projection, but it knows that all removal events are in the projection. And it knows that there's still 100 gold or not, and can add the event or not add the event. Since when acquiring a lease, you tell the lease that there will be an event, we add an empty event to the event store if there isn't 100 gold in the inventory. This system has one downside, and it is actually quite slow. But since removing events from the inventory happens not that often fast behind each other, we can actually do that. We could even optimize that and have a lease not for the inventory but also for the item type you want to remove, so that inventory gold and inventory ore, for example, have different leases. So when you remove gold and another service wants to remove ore, they don't clash with each other. We could go that far, and that would be a great performance solution. So it would be best of both worlds. But the solution with the service is as robust as the solution with the leads. But I have to develop a service with internal caching and everything, and I thought the lease is a better solution, but we could make both work. And if the business logic is more complex, For us, it's just inventory remove item, and we want to make sure that this just happens when enough items are there. If it's more complex than that, then I would choose this service solution, because I could implement in this cache a more complex business logic. But since the business logic is so simple, it's enough to basically gate remove items and make sure that the projection is up to date. So how does it look in code? I've written some tests. They do check if my system works. Maybe we start with the problem. I have my repositories and my read model handler, which is basically just updating the read model with the events. So if items are added, they're added, and if they're removed, they're removed. We had that in the last video already, but I put it in its own class so I can use it in the test. And I have a queue with the events that occur because I don't need the database. It's faster for the test to have the queue here and process it. Sorry that I jumped around, but here's the issue. And I give the player 100 gold. Let's say our daily does that. Daily login. Then we add it to the read model, so in the inventory there is actually 100 gold. The player sees 100 gold on its client. And then we have two different threads, or these are async calls, and if you don't do await, then you will get a task, and the task is basically in this case another thread. So we have two threads trying to remove 100 gold, which corresponds to our distributed system. It's even more controlled than a distributed system, but it's chaos enough for the test. And both will try to read the inventory and will check if there is enough money in the inventory, enough gold. And in both cases, I can spoiler that there is enough gold, and they add an event that they want to remove 100 gold. And they will do that. And what will happen is the player will have minus 100 gold, which is the issue we've been talking about. Now we see the player items, he has gold minus 100. The reason for that is that both of these threads add an event. If we go here, add an event, remove 100 gold, and our processor just updates the read model that 200 gold got removed, but the player only had 100 gold. And most games will say if it goes negative, I put there 0, and if you do that, then it's actually able, the player is able with some tricks to dupe items, or dupe gold in this case, and we actually don't want that. So the easiest thing, like I said, is to introduce a lease. And we have written lease management in our repository, which is just an event sourcing lease management, I called it. And there are 3 functionalities. But for the public side, there are actually 2, which is free the lease and acquire the lease. And I was inconsistent. This is async. So we acquire the lease. What will happen? We try to read if there's a lease in the database. A lease is just a document in this case. And the document has the following fields. It has an ID. It knows till when the lease is acquired. and it knows when the timestamp of the lease acquiring event in the event sourcing store will be. So we try to read that, and in the first case it will actually fail because there is nothing in the database, and then we try to create it. When we create the lease, Cosmos DB has multiple functions. It has upsert, which is insert or update, and it has create. And if two people call create pretty much at the same time, Cosmos DB will create for the first one the item and the second one will fail, which is great, which is exactly what we want. So just one creates the item, the other one gets acquired false, and just one person gets the item and acquires the lease. So let's say the lease document is available, so second or third one. Then we will read the lease and we will check if the lease is still acquired by somebody, which is easily done with the leased until. So if the leased until is in the future than we currently are, then you can't get the lease, just one person can get it. And this returns, so it jumps out. But if you can acquire the lease because the timeout of the lease has run out, the leased until, or the lease is freed, then you will lease the lease. So let's say two threads at the same time will get to 77. So it can happen that two services or two threads will get here at the same time because they both read pretty much at the same time the document. They both see the document isn't acquired by somebody else. We both get here. Now we need a database to be consistent. And what we can do is an e-tag check. When we read the document, we get an e-tag, which is basically every time the document changes, the e-tag changes. And we say now, replace the lease with my new lease, that I acquired the lease, but only if the e-tag doesn't change. And even if this method is called for multiple threads or multiple services, they can even be on different machines. Cosmos DB will run those commands like a queue, one after another, and the first one will update the document, and the second one, the e-tag, will have changed because the document will got updated by the one before, and this will fail. So the first one that acquired the document with the e-tag fine will get the lease, and the second one will have an exception because the e-tag failed and will not acquire the lease. This is a common pattern to acquire, to do lease management. The problem with that is that this alone will have this throttle time, which often is 10 seconds or 5 seconds, depending on how long you think the event will take to get to the projection. It's quite a lot of time. So let's say a player finished multiple quests one after another, and he actually has enough stuff in his inventory and he wants to fast finish those quests. And if he has to wait 5 to 10 seconds between each quest finished request, it's quite bad. So I introduced on top on the basic leasing another one, which is a fast way for the service to tell, I created the event, I want to free the lease. And it actually works the other way around. We know when we acquired the lease, I give the one that acquired the lease the e-tag. So he knows I can write that the lease is leased until it's in the past. I can just write that to the document. but I want to make sure that I'm still holder of the lease, so I check the e-tag again. So that's basically freeing the lease. Because when we don't free the lease again and we have no retry mechanism, we have this issue. Oh. This test is just testing the lease. So this gives the player 100 gold. It runs both calls. We move 100 golds, one for quest, one for trade. And we will see that the lease will block one of those. We can't be sure which one goes through first. Most likely it will be quest, but we can't be sure, to be honest. But one of those will add an event and the player will just have 0 gold, but just one of those came through. That's what this is testing. But this also has the small issue. When we check what this does, it just tries to acquire the lease, and if it acquired the lease, then it will remove 100 gold, and if it not acquired the lease, it will tell the lease blocked me. That's why one got through, removes 100 gold, the other one gets blocked. But you might see the issue here. When the player has 200 gold, he has 100 multiplied by 2, he now has 200 gold. But we do the same code again, still only one event occurs and the player has 100 gold left, even though he should be able to do both actions. He should be able to finish the quest, and he should be able to trade his friend 100 gold because he has 200 gold. And this actually doesn't happen. You see the both events that came in is one is event added, remove 100 gold, and the other one is I got blocked by the lease and I couldn't remove 100 gold. So we need to have some retry mechanism. Let's add that. So the player again has 200 gold and he wants to do these 2 actions. And because they do consistent reading now, I need another thread to update my read model, which normally is done by a whole own service. Each read model will have its own service. So in the background, it will update the model. And we will implement a retry mechanism. What we do when I acquire the lease and I added my event and everything is fine. Here I add the event and everything. I will free the lease again to not block removing items from the inventory for too long. And even though the player doesn't have enough gold in the inventory, I add an empty event so that the read model will update its own timestamp to the last event, and I know when the last lease timestamp, let me check where it is, here. When the last lease timestamp, the last leased event should be exactly the same or older than the inventory event for the inventory to be consistent with the last removal. And if that's not the case, then we wait some time and we get the inventory again, because the other service or thread will update the events eventually. That's why it's called eventually consistent. And if it eventually will update it, then this will be in this case false. It will be the other way around. The inventory is greater or equal to the last lease event. So what I do, I try to acquire the lease, and if I got the lease acquired, I do a consistent read. I try to be consistent read with the last lease. So the last lease, not my timestamp, the timestamp of the last person who got the lease before me is last event, and I check that the inventory got updated later or equal to this lease. And if that's the case, then the inventory is actually up to date. And I tried that 100 times, and I wait 10 milliseconds between each try with database latency. That's quite a lot of time. It's more than 10 seconds. So I retry to get the inventory consistent, and only if that's the case, I will do my logic. Is the inventory, is enough gold in the inventory, yes or no? And then I will free the lease after I'm done. Let me remove my test stuff, and I will free the lease after I'm done, so that the next one doesn't have to wait the 10 seconds. Here I configured the 10 seconds. So it can directly go because I finished adding my event. What happens when I can't acquire the lease? Because Quest is currently working, removing the 100 gold. Then I wait some time and I retry myself to acquire the lease again. And I have a max retry check to not have this go endlessly. And this actually fully works. I give the player 200 gold. They retry till they can remove the 100 gold with the lease. So everything is consistent. The read of the read model is consistent in that case. At least consistent for removals. If I give the player here 100 gold, I remove 100 gold and I add another 100 gold, then the second getting of 100 gold is not consistent, and is not consistent even in the consistent read. The reason for that is that we don't have consistency for adding things, but when I add things and they are inconsistent, then the client, so the player itself, doesn't see the additional 100 gold on its screen itself because he tried to trick our system. So that's not an issue. And in that case, the second one or the first one, we don't know which one, but one of them will retry till it can get the lease, and if it got the lease, it can in this case actually remove the other 100 gold. So the player has 200 gold. Trading and quest finish is possible, and we will see that both events will get added and the player has 0 gold. We can also run that. And it's done. It takes some time because leasing and database is not the fastest. Full integration test is basically going a bit overboard, and I recommend you do that when you try to develop such a robust system like partial consistent reading on event sourcing. I highly suggest you do something like that. I give the player 200 gold, but I basically try to remove 10 times 100 gold. So this is equal to the player spamming the finish quest button. And again, we expect to have the player 0 gold, not negative. And we expect to go through and 8 aren't added because the player doesn't have enough money, because we already removed 2 times. So this is returned when a player doesn't have enough money, and if the player has enough money, we say event added. And we can also run that, and it's green, so every statements that we do with assert are actually true. There are 2 ways there are multiple ways to solve this issue. One is leasing, which I decided to do because it's easy to implement and our inventory doesn't have a lot of business logic. If you have a business logic and need more consistent reads in event sourcing, then I highly suggest you do the solution with the service, so that this service is actually taking care of that only events get into the event store that are valid. What I don't suggest you do, which I saw on other things, that's why I didn't suggest it at the start, that the event processor is doing some validation. I highly suggest you don't do that. This is a read model, just a model for read, and there shouldn't be too much business logic in here. You shouldn't create events or modify the event store from the read model processor. You shouldn't do that. That feels like a break to the system. It is doable, but I highly suggest you don't do that. So you pick one of those two models that I showed you, with leasing or with another service which does gating for you and does the business logic and check if the events are valid. Because one rule with event sourcing is that only valid events should be in the event store. You shouldn't add events that are illegal. And that's it for today. I hope you all have a great weekend. And I want to really thank my Patreon Julian for supporting this project. Thank you, bye.